Hello there. Bear with me a moment. That's okay. Right, yes, so this is just a quickie. Just to keep the things live, active, because we're paying for them. But anyway, so had these blocks that were made a long time ago that never finished. Using them for a tutorial, a recent tutorial about... What was the tutorial about? I can't even remember what the tutorial was about. Let me just take a look. This is why the tutorials are written, is so that you can remember. Even then I can't remember what it was for. What was it for? Anyway, so it's all 2D. And of course, now that we're all in like super hyper 3D, using normal maps, I thought might be interesting is just trying to convert. So it's essentially it's the process of what you would need to do, maybe, what you would do to essentially convert, air quotes, convert these kinds of assets from images. So you have your image and you want to try and replicate the appearance of, in this case, it's these cubes. So what we ideally would want to be doing is looking at breaking this down into components. So we have the rim, then we have this corner decor, and then obviously we have the colored panels. So when we're looking at our 2D images, let me see if I can find those 2D images. This is Affinity Photo. Where are they? Right, so we're looking at, this was originally built, created. So it's using a normal map actually. So where is that? Where's the normal map? I think it's that one. So we've created a simple normal map essentially by converting a very basic version of the image into I think that's the one. Yeah, so we use this. I'm trying to remember because these were made quite some time ago. So these were 2D images that were converted into a normal map using a normal map converter program. I can't remember what it was. It might have been GIMP. But anyway, so it's a 2D project. What we want to try and do is essentially improve on the normal map to make these a little bit more betterer. Because one of the problems with using 2D, and this is more noticeable, zoom in, the kind of artifacts that occur that can't be really compensated for in 2D when 2D is converted to a normal map is where it interpolates, or not interpolates, what's the word? Anti-aliases. So we get these tonal variations. And because of the way that normal maps work, this isn't seen as a sharp cutoff. So this should be a sharp edge. It's actually seen as something that's akin to That's a darker color, so it would be a ramp, I guess, like that, rather than what we actually want is something that's similar to this. So we want the normals, the color of the normal map, to correspond to this sort of shape, but what we end up with is this. And when we look at that in 3D, I don't know how easy this is to see. When we look at that in 3D, we get ghosting around the edges of things under certain circumstances, and if, particularly, we are using things like specular and special effects, because it can't create that sharp edge. So the interpolation ends up with these artifacts. There, we can see it a bit more clearly there. And that creates the impression, well, it ruins, it breaks the illusion. So that should be a dip before it gets to the edge of the box. So there should be a dip there. But because of the way that that highlight strikes the, well, because of the way that it's rendered, we end up with something that's highlighting what should be or is the wrong edge. So essentially what we want is a highlight on this side, but what we end up with is a highlight on this side. That's the disadvantage of converting 2D images to a normal map. So ideally what you want to be doing is, as best as possible, making your objects in 3D and baking your normal maps from your 3D images. So this little project won't be going on for too long. Don't have enough time, unfortunately. So what we're going to do is we might be able to actually use one of these boxes as the template for our shape and our editing. Just close that. And that's relatively straightforward for an object like this, because it is such a formal, regular, simple shape. Obviously, the more complex the shape, the more work has to go into making sure that you are shaping your mesh to match the texture assignment. So let's use this pink one. Let's go to duplicate, move that to one side. Then we can go into edit mode, loop cut half, loop cut half, loop cut half. Let's just focus on the object. So the only reason for doing that is to symmetricize, make the object symmetrical, so that when we do another loop cut, oh, where's the is it clamp? I should be able to correct UVs whilst transforming. I'm not sure why that's not working. It's smushing the UVs. It shouldn't be doing that. Is it clamp? No, that's not the one. No worries. Because what we can do it manually then. So double tap G key, hold control, snap to the grid, and it's still doing it, which is the That should be. What's the This is Blender 2.35, so have they done something again? Okay, let's try that. Oh, there we go. So it's either it's moved or something. Double tap, hold control, snap. Get it as close as we can. Loop select, double tap, snap. Double tap, snap. Whoops. Undo. Double tap, snap. So run the rest of the box. Double tap, snap. What we should have is that. So let's see. Let's try just extruding downwards. What is that? 0.0. Let's go with 0.02. 0.02. Whoops. Damn it. Minus 0.02. Might have to inset this because making a normal map to a flat texture doesn't like sharp forelots. Because normal maps don't generally deal with height information if we're baking to a flat image. So it won't understand this, not instep, this indentation. So we might have to shrink this down a little bit. So scale. Go 0.7. And then for the filigree, or that corner, let's go with so what we could do there is duplicate that face. Hit select. So a lot of this is just pretty much doing things on the fly. Going to top down. Shrink. That's not quite. Let's just select that. Whoops. Whoops. Have they? Let's just get that to 5 and that one to 5. That one. And that one to 5. So that is now, midpoint, 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 midpoint. That's okay. Actually, let's just leave it up there. Edge select. Extrude. Similar issue to the inside edge. We have to scale that a little bit so that this shape, otherwise the normal map's not going to pick it up. Class. We can drop that in the corner. Let's do a selection to cursor. No cursor to selected. There we go. Duplicate. Rotate around cursor. 1, 2, 3, 4. Rotate. Whoops, a daisy. And rotate. So what may be a better thing to do is to just do, because what we could do instead of doing each of these so that's one face repeated 6 times per cube for each color. And separating out the frame, separating frame from the color, we could map the frame itself just to one bigger image or one area of the image and then use what's left for just the individual colors. That would require, so, whoops, didn't need to do that. Let's do select, separate. Whoops, not duplicate, separate, P, separate. But then that gets tricky. To then bake the normal map because we need a corner, we need an edge. We want that to be done via the normal map. Let's rejoin that. Mesh, remove, merge by distance. Because all we need is basically this top face, but the top face has to interface with the edges correctly in order to get the normal map that we want. We can see that if port wireframe subdivision surface. Let's double check we don't have select all mesh or mesh edge, clear seam, clear sharp. So one, two, three. 1, 2, 3. Control key is your friend. Oops. Split that. Whoops. the edge gone? 1, 1, 2, 3. So we're using the mesh to create our sharp edges. But we don't necessarily want them like diamond sharp. Five. Because obviously at distance you're not going to see that, but it helps that it is there in the baked normal map, because it changes the characteristics of the rendered surfaces. I mean, if we wanted, we could use this. How far down did we go? That will be the sharp edge. That's what we could do. Use that inside surface as the face. So we don't do anything, we don't need to add anything else. We can just use the structure that we've already got. Hyperinflate it. So we're overcompensating for the fact that this will be baked to a 2D image. Might have to do a little bit of fiddling though. But what we can do is, because we're baking this to a 2D images, what we sometimes have to do is overcompensate, because the process of converting the 3D converting the 3D back down into 2D, because we're then going to place that onto this 3D structure, because we're then going to place that onto a flat surface. The fact that it's on a flat surface, even though this might be a normal map and all the structure is where we need it to be, the fact that it's on a flat surface can often mean it kind of neuters the 3D effect of the normal map. What that often means is that you sometimes have to overcompensate for the pattern or whatever it is that you're making. You have to overcompensate in order for it to do what you're actually expecting it to do visually. So with these corners, because we need to be able to get this little trim section in, we bring it down as, you know, to give room, to allow room to accommodate those little features. But we have to be aware that the shape, the physical structure, has to be different enough that at whatever size the image is going to be baked to. So if we stick with 256 by 256, which is this, is that. If we stick to a 256 by 256, the curvature, there it is. The difference, so this subtle curve might not register very well in the normal map because of the size of the image. So we have to compensate, but we have to be aware of the fact that if we compensate, we might create problems elsewhere. So there's a lot of playing around with the shapes to try and get them working correctly or working as expected. So let's try umphing this. Just do one and then we can duplicate it, but so just create the halves and the halves not. One, two, three, two, oops. 1, 2, 3. So that's along that edge. 1, 2, 3. 1, 2, 3. Whoops. Double slide. 1. 1, 2, 3. 1, 2, 3. And in the corner. It's a bit too sharp. One, two, three. 2, 3. Okay. That'll do. So just select these as Control plus, just delete them, don't need them anymore. Actually, just separate them. Just keep them to hand, just remove them. Top. Duplicate, rotate. 1, duplicate, rotate. 2, duplicate and rotate. That's 4. Drop those into place, and there is, or there are, our trim sections. But might have to I don't know if we're going to be able to do this. Oops. Oops. Go. Yeah, we don't have. What I might have to do just temporarily is just delete these edge loops. So X, dissolve edges. That's better. Right, so what we did there was, so when these were temporarily just put into position, this bevel wasn't sufficient enough for it to be clear that there should be an edge there. So simplest way to do that without doing too much mucking about or redoing these is just to delete, not to delete, is to just shrink the bottom up. But we had an edge loop in the middle that we were using to define the shape, so we've just got rid of those so that we can push the bottom edges up and increase the angle of that wedge, the shape. And what that should mean is that when these are dropped back down into place, we've got a better, slightly better edge showing, which should aid the bake process. So that's our one side of our face, and this is what we'll bake. We'll do this in another stream because I only had a short amount of time. So what we'll do is, that is our simple face. Let's just enable textures. So we can see it's still got obviously the previously mapped images to our cube, and we can see the difference that that makes having actually modeled that, and how that then makes the texture appear on our model versus the flat surface of the cube. So what we want to do, that bodes well for when we bake this as a normal map, so that we can then apply it to each side of the cube. So that curve comes through nicely. And again, it's overcompensating for the fact that we're going to be on a flat plane. So we can overcompensate and make this quite high so that we get a decent curve appearing in the image. But we'll do that on another day. So this was only going to be quickie, just to keep everything rolling. But that is converting, air quotes, converting a 2D image to a 3D structure, albeit this is a relatively simple, straightforward, angular shape. It's the same process for everything. Right, oops, save the file. Save as 6. Yep. Right, so we'll call it quits there, and we shall see you on the next video, whence we shall try baking the normal maps and sorting out how we want to organize the UV mapping for our cubes to try and take advantage of the fact that we have now got a 3D reference object that we can bake from. So we'll take a look at that in the next stream. Right. Thanks for watching, lurkers, and we shall see you next time. Bye for now.